Hello my dear students, welcome to my third session of moving charges and magnetism, and in this particular session we will be taking a look at comparison of Biot-Savart law with Coulomb's law. We will take a look at similarities as well as differences. Okay, so now proceeding to the first part. Now here let us go ahead and state both of them mathematically as we had derived in case of electrostatics as well as in this particular chapter. So I'll first go with the Biot-Savart law statement. So according to Biot-Savart law, we can see that the magnetic field produced by a current element I into vector dl at a distance r is given by dB is equal to mu naught by 4 pi into I dl sine theta divided by r square. This particular expression we had derived in my second session. I hope you all can recall that. Now let's move on to the next second one, that is Coulomb's law. Now Coulomb's law, according to Coulomb's law, we can say that the electric field produced by a charged element dq at a distance r is given by dE is equal to 1 by 4 pi epsilon naught into dq divided by r square. So this is statement wise expression that I am making. Now let's move on to the similarities firstly and then differences. We'll take a look at that. We shall take a look at the comparison as similarity firstly. Okay, so if we just try to take a look at the similarities, my dear friends, you can notice here both the laws define the fields dependent on inverse of the square of the distance from the source to the point of observation. That point of observation, I had told you in my second session that I called it as reference point. If you remember, point P we had marked. Okay, so that reference point I am talking about. So in both the laws, like in case of electrostatics, the electric field, what is the source? Source is charge. Similarly, in case of moving charges magnetism, Biot-Savart law, the source of magnetic field is what? Source of magnetic field is current element. Now, both are separated by distance r from that source point. So, accordingly, we can very easily say that both of them obey inverse of the square of the distance from source to the point of observation. I hope I am making it out very clearly. So, hence, in very simple way, I can say that both these laws are inverse square laws. Okay, there are certain laws in physics called as inverse square laws, and one amongst them is Biot-Savart law, and as well as Coulomb's law is also one amongst them. So hence, in short, we can say similarity number one, both of them obey inverse square laws. So I hope this is clear. Now second similarity, both the laws define their respective fields as long range fields. Like electric field is long range, similarly magnetic field is also a long range field. So hence Biot-Savart law and Coulomb's law, both of them, they define their respective fields to be what? Long range fields. Okay, so this is one more thing. Then third similarity, as magnetic field is linearly related to its source, namely the current element I into dl. That means during Biot-Savart law I have told you that dB is directly proportional to I, dB is directly proportional to dl. So very clearly dB is proportionate to what? I into dl, right? Similarly, electric field is related linearly to its source, namely the electric charge, and we know that dB is directly proportional to dq. Now with reference of these two, we can understand one intriguing fact, my dear friends. If at all remember, the field is directly proportional to the magnitude of the source, then that particular law will always obey principle of superposition. So hence what we can conclude here, both the fields obey principle of superposition. That means Biot-Savart law and Coulomb's law, both of them are in obedience with what? Principle of superposition. This is what we can understand about the similarities. To be a quick revise on this first one, both the laws define fields depending on what? Inverse of the square of the distance between the source and the reference point. Okay, that is what we are writing here. And second similarity is what? Both the laws define fields as long range fields. And third one, both the fields, electric and magnetic fields, they respectively are directly proportional to the magnitude of their sources. So due to that reason, they obey superposition principle. This is what we can understand regarding the similarity. Now let's proceed to the differences. Now let's take a look at the differences between Biot-Savart law and Coulomb's law, my dear friends. Okay, so Biot-Savart's law, we can say first point as source of magnetic field is a vector. Is it not? I into vector dl is a vector. So hence source of magnetic field is a vector quantity in case of Biot-Savart law, whereas in case of Coulomb's law, source of electric field is a scalar quantity, that is electric charge dq. Correct? So hence this is our first difference that we can make out between Biot-Savart law and Coulomb's law. Then second point, in Biot-Savart law, direction of magnetic field is perpendicular to the plane containing the position vector, vector r, and the current element I into vector dl. Correct? So direction of magnetic field is perpendicular to the plane containing position vector, vector r, and the current element I into vector dl. That means I am talking about the cross product. Remember, my dear friends, we had derived that vector form of Biot-Savart law. In that vector form, we had very clearly derived dV is equal to mu naught by 4 pi into I into vector dl cross vector r divided by r cube. Do you remember that? Now, what is vector dl cross vector r? Is it not the two vectors? Vector dl is one vector and vector r is second vector, and vector dv will have a direction along this cross product, no? So obviously cross product is always directed along the normal drawn to the plane containing the two vectors in the cross product. Remember our discussion during first PUC on cross product. So cross product will always have a direction perpendicular to the plane containing the two vectors in the cross product. Now here two vectors are what? Vector dl is one vector and vector r is second vector, and if you design or draw a parallelogram containing these two vectors, then the cross product will have a direction along the perpendicular drawn to this particular parallelogram. I hope it is clear. So hence we can comfortably understand here that direction of magnetic field is perpendicular to the plane containing the position vector, vector r, and the current element I into vector dl. I hope it is clear. Now in case of Coulomb's law, direction of electric field is always along the position vector, vector r, joining the source and the field point. It is not perpendicular, my dear friends, here. It is always along. So source will be placed somewhere here and direction of electric field will be along this particular direction of vector r here. Remember electric field chapter? Okay. So that same direction we are talking about here. So this is one of the intriguing difference between both the laws once again. Okay. Now let us take a look at third difference. The magnitude of the magnetic field is proportional to the sine of angle between the current element I into vector dl and the displacement vector, vector r. This we have seen already in case of Biot-Savart law. Remember that? So very clearly we can understand that magnitude of magnetic field is directly proportional to the sine of the angle between the current element I into vector dl and displacement vector, vector r. That is why we have sine theta in Biot-Savart law. I dl sine theta divided by r square. Remember, so that sine theta I am talking about, SINE sine, okay, it is not SIGN. I am talking about sine, SINE, okay, sine of angle. That angle is theta we have taken over there, so that we write it as sine theta. Remember that, okay. So whereas in case of Coulomb's law, we don't have any of such hassle. Here we have magnitude of electric field has no dependence on such angle. There is no dependence on such particular angle at all here, my dear friends. So hence we can say that this is one of the difference, striking difference between both the laws that we can understand. Okay, so these are some of the similarities and differences between the Biot-Savart law and Coulomb's law. I hope it is clear. Now let us move on to the derivation of relationship between mu naught and epsilon naught. Mu naught permeability. Remember, I had explained to you during my discussion on Biot-Savart law. Permeability is mu naught and absolute permeability. I am sorry. And epsilon naught is what? Absolute permittivity in case of electrostatics. Okay, we'll try to derive a relationship between these two now. That is what we will be doing right now. So let us go ahead and do that now. Take a look at the relationship between mu naught and epsilon naught. I hope you know what is mu naught. Mu naught is absolute permeability and epsilon naught is absolute permittivity. Let us go ahead and derive the relationship between them. So we can say that 1 by 4 pi epsilon naught is 9 into 10 raised to 9 Newton meter square per Coulomb square, and mu naught by 4 pi is 10 raised to minus 7 Tesla meter per ampere. That I have already discussed during my Biot-Savart law session. Okay. Then we will multiply it simply. Then we will say mu naught into epsilon naught. That for that product I will multiply and divide by 4 pi. So we can easily see here that I have multiplied by 4 pi and divided by 4 pi here. As you can notice here, I hope you can make that out. Okay. So now our next job is quite simple. Since we have written it as mu naught by 4 pi into 4 pi epsilon naught. So in the next step what we'll do, mu naught by 4 pi into 1 divided by 1 by 4 pi epsilon naught, because 4 pi epsilon naught is 1 by 4 pi epsilon naught, correct? So that adjustment we have made here. Then we will substitute their values, very simple, 10 raised to minus 7 into 1 by 9 into 10 raised to 9, okay, and this works out to be 1 by 9 into 10 raised to 16, and that I am writing it as what, 3 into 10 raised to 8 whole square, as you can make it out. And thus we know that 3 into 10 raised to 8 whole square is nothing but c square, because 3 into 10 raised to 8 is nothing but the speed of light in vacuum. So hence we can write it as 1 by c square. Okay, therefore finally we will say c square is equal to 1 by mu naught into epsilon naught. Therefore c is equal to 1 divided by square root of mu naught into epsilon naught. I hope this part is very much clear to you all. This is clear, right? So this is the discussion that we were planning to have, and this relationship between mu naught epsilon naught, you please remember, even you require this particular relation, its value in case of modern physics as well as in case of optics chapter, like in wave optics. So kindly remember this particular relation. Okay, now with this we are finishing with our discussion. So let's summarize what we have learned now. Let us go ahead and do a summary of it. So today in this session we have learned about similarities between Biot-Savart law and Coulomb's law. Then we have learned about differences between Biot-Savart law and Coulomb's law. Then we have understood the relationship between absolute permeability and absolute permittivity, and we have made a derivation for that. Okay, so with this note I would like to say we are done with this particular session. So in my next session I'll come up with applications of Biot-Savart law, that is derivation of a magnetic field due to a circular coil along its axis. So that particular derivation we'll see in my next session. I suppose this particular discussion part was clear to you all. So finally, let us go ahead and sign off. Thank you and see you soon.